All right, welcome back, everybody. My name is Dustin, and today we're going to be diving into the Pimpl idiom in C++. It's a smart way to hide implementation details, speed up compile times, and improve encapsulations. And today we'll cover the basics with a practical example and a more advanced one. So let's go. So what is the Pimpl idiom? Pimpl stands for pointer to implementation. Instead of exposing private members in the header file, we hide them behind a pointer to separate the implementation from the class. So why would we use this? The Pimpl idiom reduces compile time dependencies, it keeps header files clean, and it also improves encapsulation. Without using Pimpl, even a tiny change in your class can force a full recompile of all dependent files. With Pimpl, only the CPP file needs to be recompiled. It's also a really good way to hide your implementation details. For instance, if you don't want them to know how you're implementing something and you just want to give let's say you're creating a library and you just have an API and you just want to give them the basics of what the class has and not show them the underlying code, it's a good way to hide it with a pointer. All right, so let's see this in action. So the first thing we're going to do is create a person class. So let's go up here and add a new file. In our source, we go new file. And we'll call this person.hpp. And we're going to want to include memory and string. And we're going to have our class. It's going to be a person class. And we're going to have some public, private. And for our private, we're going to have our class Pimpl. And we're going to have an std unique pointer to that implementation. We're going to call that MP Pimpl. So the Pimpl is going to be the actual implementation of the class that we're going to want to define in the CPP file. We're not going to tell it what the person consists of, just that we know that it has a implementation hidden somewhere else. So the Pimpl is actually going to be a class from person, but we're only going to forward declare it here. So we have our person, and a person is just going to be a regular constructor with a const std string. It's going to be the name, and it's going to be the age. And we're going to need to have person, a destructor here. This is required because we have incomplete type here with the Pimpl or the implementation. So for the unique pointer, we need to actually have the destructor and define that in the CPP. So if you notice here, we declare the Pimpl class, but we're not actually defining it. Instead, we're just using the unique pointer to manage it. This is kind of basic. Let's add a function. So we'll say void introduce. And this can be const. And now let's implement this. And we can create all of these. Go back here, create this. We created those. All right. So now that we have our person, we need to know how to define it. So the actual implementation of the person is going to be done in the Pimpl class. So we need to create that now. And we can go class person Pimpl. So this is the actual implementation of a person. As you can see, this is in the CPP file, and we're actually doing the definition of the class here. In the H file, this is just a declaration. So this is a forward declaration of the class, but we haven't actually defined it yet. And that's what we're doing here in the CPP file. So then this will also have a public, this will have a private, and this is where we're going to actually hold on to the private members. So instead of exposing the private members of person to the world, so whoever has access will have access to, say you have an API or a lib, but they won't have access to the implementation details because that will be the binary file or the lib file that we give them, right? Or that they compile. Unless they have access to the source code, then you know exactly what it has. So we're going to have some private, and that's going to be a string. It's going to be std string m name. Then we're going to have the age. Let's say m age. And here we need to have our constructor, and that's just Pimpl. That's going to take in a const std string reference name int age m name m age. That's all we need for the constructor. And then we're going to have the introduce function as well. So we can say void. So even the introduce is actually done in the Pimpl or in the implementation. So we'll say void introduce const. And then up here, let's add, I'll go up to the top and let's include IO stream. And we can go std, cout, hello, I'm name, and I'm am age, years old. Pretty straightforward. So that's the actual underlying implementation of the person. Okay. So what we're going to want to do here is mp impl std make person impl. It's going to be name age. That's our constructor. And our destructor, you can just leave it like this, or you can make it into a default. And then our introduce, for the introduce, all we're going to do is actually call the implementation. So we're going to go mp impl introduce. That's it. So as you can see here, all that's there for the user is the implementation. It doesn't know what's actually in the person or the member variables. So it knows that it has a person. It could have a name or age. It doesn't know how it uses it. And it does the introduce. That's all done in the back. So let's actually test this out. Go here, go include person.hpp. Let's create a person. We'll say person. And then we can just say John. And John is 25. And we can say person, not a pointer, introduce. And run. See, so what it's doing here is it's calling the implementation. We don't have access to the implementation because it's hidden. So we don't know how the introduce function is actually working. And we don't know the member variables. So the implementation is completely hidden inside of person.cpp. Any changes to impl won't affect the header file at all, keeping compile times low. Pretty straightforward, right? Well, that was a simple example. So let's look at something more practical. And we've used this a few times, a logger class. Let's create a logger class right now. So we can do the same thing, create a new file, add, new, header file, say logger.hpp. So we have a logger, and we can say class logger. We're going to want to do the same thing with the memory and string. Memory include string. We have our logger class, and we want to have some public. We're going to have private. And we're going to make the logger a singleton. We went over that in the previous video. You can check that out right here of why singletons suck, or is there better alternatives? Let's actually just make this into a singleton. It's pretty straightforward. So static logger reference get instance. And then we're saying void log const std string reference message. Since it's going to be a singleton, if you remember, we need to make the constructor private. So logger. We're also going to want to have a destructor here. Logger, that's needed because we're going to do the unique pointer again to the implementation. We might as well delete the copy constructor and the copy assignment operator. So logger const logger reference equals delete. Copy this line down. Operator should have those there. Awesome. And once again, we're going to have an implementation class. So we're going to go class impl. You can call it whatever you want. I'm just going to call it impl and std unique pointer to impl smp impl. Whoever uses this logger class, all they're going to have access to is the get instance and the log. Even if you look, so if you only have the header file, you're just going to see the logger class. You're going to say, okay, it's singleton, and there's an implementation. You're going to see right here, it's a pointer to implementation. So it has no other member variables available for you to see. All those details will be hidden in the CPP file. So let's actually grab this, try to make these. Let's create those three and go implement this. So we'll go to our CPP file. So now I'm actually going to want to make this a thread safe logger. That's another thing. The user doesn't know that this is thread safe. We're going to let them know. We probably let them know in the documentation, but they don't know how we implemented that. So what we're going to do up here is that we're going to include a mutex. So include mutex. And we're also going to include the fstream because I'm going to want to write this log to a file. Okay, so and then we'll also include iostream. So we can also write to the console. Okay, so before we implement these here, we need to do the implementation class. Okay, so let's go class logger impl. All right, so we have our impl. We're going to go public, private. So what do we need to make this a thread safe implementation? We're going to need a mutex, but we're also going to want to log it to a file. So we're going to need an ofstream member variable or offstream, ofstream. We'll say offstream, std offstream log file. And we're also going to say std mutex mutex. Cool. So we have those. And now we want to do our constructor and destructor. So import. And it's going to just open the file log file.open. And it's just going to be log.txt. And we're going to want to append. So every time it's run, it's going to append to that file. iOS append. Cool. Now we're not going to check if it's open here or do any errors. We're just going to assume that it worked. So let's do the destructor. And in the destructor, this one, we actually want to close the file. So if it's open, so log file.isOpen. So let's close it. Log file, close. Awesome. So this is that RAII stuff that we went over in another video. It opens a file and needs to close it as well. Okay. And it does that on destruction. The user doesn't have to worry about that. Cool. And we're also going to do the log. Let's go void log const std string reference message. Bring that down. And we're just going to use a lock guard. There's no need to use a unique lock here because all we're doing is locking the mutex. We don't need to open it or use a condition variable or anything like that. So we can go std lock and mutex. And now we can do our logging std cout log message end line, and if log file.isOpen, this is where we're going to check to see if it's open, and if it is open, we're going to write to that file. So log file. Actually, we can just copy all of this. Awesome. So that's it. That's our implementation there. So we're opening a file, we're closing it on destruction. And in our get instance, it's the same as always here. We're going to want to go static logger instance turn instance. And the log, all we're going to want to do is call the implementation. So Pimpl log message. That's it. And then in our constructor, we can go Pimpl std make unique logger Pimpl. That's it. No arguments needed to be passed in. And this can just be set to default. Awesome. There you have it. You have a minimal example of a thread safe logger where the implementation is hidden using the Pimpl idiom. So now let's go back into our main and see if this works. Main.cpp. All right, so here we can include the logger. And we're also going to want to include thread, and we're going to want to include vector. Now we might as well include format as well. You can use std format or fmt format. I have fmt, so I'm going to use fmt format. Awesome. And all I'm going to do here is go std vector of std thread, and I'm going to call this threads. And then I'm going to want to just have 5 threads. So int I equals 0. I is less than 5. 5++. Then I'm going to want to emplace back my threads. In this case, I'm going to want to use a lambda. So let's go threads.emplace back. And I can use a lambda. And I'm going to want to capture I, because this is basically going to be the current thread. It's not the real thread ID. We could add that in later, but this is the thread that I'm currently using. And we don't need to have any arguments because we're capturing I. Then we can go for int j is equal to 0. J is less than 5. J++. And here, now we just have to get our logger. So we go logger get instance log. And we can go fmt format thread message, send in I, send in J. Oh, that doesn't need to be there. Awesome. What this is going to do, it's going to create 5 threads. It's going to bind this function to it. Now, the good thing about get instance is it's thread safe, because ever since C++11, static variable is guaranteed to be only created one time. So it will be a proper singleton. And let's go back here. And we're going to have to finish by joining them. And we can go for auto reference thread in threads. And we're going to want to say just thread join. And then right here we can go logger get instance log all threads are finished. Awesome. So let's try this out, make sure it works. No errors. Awesome. Look at that. So looks like it's all printing out nicely. No threads are going over each other. Very nice. Perfect. So we have our log. Now that's to the console. Let's see if it created our log file. And it did. So there's our log.txt or txt. Let's open that. Boom. There you go. So that worked out perfectly for us. So now we have a thread-safe, file-based logger using the Pimpl idiom. No exposed private variables, no messy includes, and it's easy to maintain. If we want to change anything in the implementation, we can, and we don't have to worry about anything here because we have a pointer to that implementation. All right, so why use Pimpl? Some of the benefits of Pimpl are you end up with better encapsulation. So you have no private members in the header except for the implementation pointer. You have faster compilation. Changes to the CPP file aren't forcing recompilation of dependent files. You have stronger ABI stability, so binary compatibility between versions is much better. And this is especially useful for large projects and library development. So if you're making libraries, this is very useful because then you don't have to show the world, whoever's using your library, what the implementation actually is or what the members are, so they can kind of deduce it on their own. So that's it, guys. That's the Pimpl idiom in C++. If you found this useful, hit the like button and subscribe for more C++ content. Also, let me know in the comments below if there's anything else you would like me to talk about, or if you've used Pimpl in your own projects. All right, that's it. Take it easy.